All right, so let's do this. Let's create a new code cell. And now the first thing that we have to do is call the matplotlib.pyplot module, which has a shortcut plt. Then from this module, we're going to call first the scatter function, which will allow to first, display on a 2D plot the different points of coordinates containing the real results, the real position levels going from 1 to 10 and the real salaries. So that's what we are plotting first, and then we'll plot the predictions. And so, well, here we have to input first the coordinates of these real points containing the real position levels and real salaries. And on the x-axis, we have, of course, the position levels. Therefore, the x-coordinates will be x, all the position levels contained in x. And then on the y-axis, we'll have the salaries, the real ones, and therefore the y-coordinates will be y. All right? And then remember, we need to add a color, and we'll choose, like last time, red. Perfect. So that's for the real results. And now we're going to plot the predictions. And to do that, well, we're going to call plt again, matplotlib.pyplot, from which we're going to call the plot method, because this time we're actually going to plot that regression line, in blue, like in simple linear regression. And then for polynomial regression, you will see that it's not a line, but it will be actually a curve. And still, we will use the plot function for that. So again, we have to enter the coordinates of the different points of this line. And for these coordinates, well, first, the x coordinates are still x, the position levels. But then the y coordinates will be, of course, the predicted salaries, instead of the real salaries. And to get them, well, we simply need to call our linreg object, not linreg2. Linreg2 is for the polynomial regression model. Linreg is for the linear regression model. And so linreg, from which we're going to call that predict method, applied, of course, to x, right? Containing the position levels of the matrix of features x. All right, and then we add a color. And like last time, we'll choose the color blue. All right, blue. And then we'll just improve or enhance our graph by adding a title, an X label, and a Y label, and finally display it. So you know how to do this. We call first plt, then the title function. So here we're going to add a funny title, like in quotes, of course, truth or bluff, right? This is the simple scenario I invented for this case study. And then we're going to precise that it's linear regression, the linear regression model. Okay, good. Good title. Now, an X label. So here again, plt.x label. And we'll choose, something simple like position level. Okay, perfect. Then a Y label. So I'm calling the Y label function. And we're going to enter salary, because on the y-axis are all the salaries, the real ones or the predicted ones. And finally, remember that we have to show the graph by using this show function. Perfect. And there we go. We're already ready to visualize the linear regression results. Are you ready? I'm going to close this so that we can see it very well. All right, let's make sure I didn't make any mistake. Yeah, it seems all good. So now let's press play, and here we go. This is the linear regression results. Let's scroll down a bit. All right, so first of all, to recap, the red points here are the real salaries, going from 0 to, I think, 1 million for the CEO. Yes, okay. So these are all the real salaries of this column, okay? And then the blue line is, of course, the regression line containing all our predictions, but the predictions of the linear regression model. So, first of all, we can see that, indeed, the linear regression model is not well adapted to this dataset. Because, indeed, remember that in simple linear regression, it was well adapted because each time, for each of the values of the features, well, the prediction was close to the real result. But here, for many position levels, for many values of the feature, well, the prediction is far from the real result. Here, for example, it is quite far from the real salary. Imagine if we wanted to use that model to predict if someone is saying the truth or bluffing about a salary that is contained here. Well, we would have offered a way higher salary than we would be supposed to. So that would not be the best negotiation. Okay, so that linear regression model is not well adapted. And same here, it is far from the prediction. Same here, far from the prediction. Here it's okay, but you know, that's only for 2 points, 2 salaries. But then here it's super far from the prediction, and here as well. So clearly not well adapted, and that's why I wanted to show you this, because now you're gonna see that the polynomial regression results are gonna be much better. And now I'm gonna show this to you right away. So I'm gonna close this, and we're gonna visualize the polynomial regression results efficiently by taking this code, because you're gonna see that it's gonna be almost the same. So I'm going to scroll down, I'll scroll back up to compare, create a new code cell, pasting that here, and now according to you, what do we have to change here? Actually, something important. Please press pause on the video now and try to figure out, before I give you the solution, what you have to replace here in order to visualize the polynomial regression result. So please press pause on the video and make that change in order to make it work for polynomial regression results.